Good morning to Adrian. Good evening, late good evening to Paul Whittle in Sydney. And of course, good afternoon to everybody else in India. This is the fourth session today by Adrian Shooter on the electrification without the wires. If I may be slightly allowed to have a small observation, when Adrian came on the screen, I could see his hand and he set his clock to the Indian Standard Time, which was quite interesting. So see by your watch, Adrian, so we can start. The moderator for today's session is JL Singh, Secretary of our society. He is, of course, a mechanical engineer by qualification and a railwayman. Of course, he joined the railways, and his basic interest now is rail enthusiasm. He has spent a lifetime in the railways, retired from active service, but not from the railway world. He is the secretary of the Rail Enthusiast Society and the editor of our quarterly magazine. And as a part of his work in the Indian Railways and with the Rights Limited, where he worked earlier, he has traveled widely and worked with railways in all various parts of the country except Antarctica, giving him a comprehensive picture of rail activity and rail enthusiasm the world over. So I now hand over to Mr. JL Singh, the moderator for today's session, and welcome Adrian.
Thank you, Manoj. Adrian, I hope you are there.
Yes, I am. Can you hear me?
Good. Anyway, ladies and gentlemen, I have the privilege of introducing Adrian Shooter, who is from the United Kingdom. I first met him about 5 years back when he was here in India and accompanied him to the Rewari Steam Locomotive Depot. Subsequently, we have been in constant touch and he has contributed an article in one of our issues, one of the very early issues of our magazine, The Rail Enthusiast. This was regarding a trip he had made on the narrow gauge sections around Vadodara. Adrian has been a professional railwayman all his life from a very tender age. He joined the Festiniog Railway Society at the age of 14. Very interestingly, he has a 2-foot gauge railway running in his garden for the last 20 years. And what is even more interesting for Indian rail fans is that the locomotive that runs this railway is a B-class locomotive of the Darjeeling Himalayan Railway. If I recall right, it was not purchased from the Darjeeling Himalayan Railway, but from the USA. Is that right, Adrian?
Yes, that's right. It was bought in 1960 by a gentleman from Illinois, and I bought it from the States about 20 years ago.
Of course, Adrian went on to join the British Railways as an engineering graduate long back in 1970. Rising through the ranks, he led a management buoyant for Chiltern Railways in 1996 and went on to demonstrate that railways really can be a means of stimulating economic development. After retiring in 2011, he set up Vivarail Limited, which leads the way with railway decarbonization. Today, he will be talking to us about Vivarail and the work being done to produce zero-emission rail transport. This goes with the title of his talk, which is Electrification Without Wires. So over to you, Adrian. The screen is all yours.
JL, thank you very much indeed. And I would like to say, having looked at the list of participants today, there are many old friends, many people I've known over the years. So hello to all of them, including Mr. Ranjit Verdi, your commentator on the last presentation. Now, I've got a presentation which I'm hoping is going to be screen shared. Could that be done, please?
Poor, could you do that?
So give me 1 second. I'm just sharing the screen.
Yeah.
Right. Now, as I was explained, I retired from full-time work in 2011, but decided I wanted to do some more things. And in particular, I wanted to bring about some change in a certain area in the UK. Now, listening to the last presentation, very interesting. Mr. Verdi observed that India has a democratic system, so does the UK. Both have the consequence of changing plans, and we've certainly seen changing plans in the UK. But one thing that was coming clear a number of years ago was that, seeing as unlike India, the UK will not have a fully electrified system probably ever. Only about a third of the network is now electrified. Really, we ought to be looking at trains that can be electric but don't require the electrification system. Now, this picture just takes you very quickly through some of the things that my very small company has built over the last 8 or 9 years. Now, a so small company, we have about 120 employees, engineers, designers, manufacturing people, technicians out in the field. Next, the very first train we produced was this one. Two years from setting the company up, we had a 3-car diesel electric passenger train in service, passed all the approvals required under the law so that it can carry passengers on the main line. So we didn't actually run it in service with any company, but we operated on the main line to test it, and obviously found many things that needed improving, but it worked. Next, please. Next picture,
Yeah,
please.
sure, sir.
Right. Soon after that, we built our first battery train. Now, this is just a 2-car train, both cars powered by battery. We're showing it here on a private railway in Scotland because at the time, it didn't have all the approvals necessary to go on the main line. But we wanted to run it as far as we could to test out the concept, which basically was sound, again requiring quite a bit of development. Next, please. Our first actual order where we sold trains to a customer was for these 3 trains. And although they're shown on the maintenance depot, which, as you can see, is electrified, these 3 trains are diesel electric. Everything beneath the floor, so the entire interior of the train is available for passengers. Now, it was observed earlier on that my watch was set on Indian time. That is, in fact, because I'm in India. I'm speaking to you from a hotel room in Bombay. Now, this morning, I went with my wife to VT just to have a quick look, and noticing the extremely long EMUs they have there, I must comment that these trains are only 2 cars long, because the UK clearly is much less populous than India, and many branch lines carry very few people. Now, these 3 trains, however, have been in service very successfully for 3 years. I mentioned that they're electric. However, we've now been asked by the company that operates them if we will give an estimate for converting them to full battery. And because we designed them with that in mind, that will be fairly straightforward. Next, please. Next, please.
Yes, sir. So nice.
Right, the next order that we had was for 5 trains. Now, these trains are hybrids, which is to say they're 3-car trains. The driving cars at each end are powered by batteries, and they will go 60 kilometers on battery alone. The middle car has 4 diesel gensets under the floor and normally charges the batteries. So this is what we call a diesel battery hybrid. The reason that the customer ordered this train was because they want a high rate of acceleration on a particular branch, because keeping time on a branch with steep gradients and sharp curves and many stations was difficult with the existing DMUs. These trains will accelerate at 1 meter a second squared, which is the kind of acceleration you will typically get on a metro train. Also, if they're in sensitive areas, the engines can be shut down and they can proceed on battery only. So these were the first battery hybrid trains in the UK. Next, please. There again is one of the on main line. And again, we had these approved to carry passengers, which is quite a testing process in the UK. And despite Brexit, we use the same system still as is used throughout Europe to get approvals. Next. Our next order were pure electric trains. If you look carefully in this photograph, you can see the third rail, and this is on a place called the Isle of Wight, which is a small island just off the south coast of England. It's part of England, but the railway on it is no more than 12 kilometers long. Surprisingly, it is electrified, and this was a small fleet of 5 trains, 4 of which you can see in the picture, which we supplied, and they've been operating since last year. Next, please. Right, this picture is taken in Glasgow Central, which is the main station in Glasgow in Scotland. And it was taken during the recent UN climate change conference known as COP26, which ran for 2 weeks in November last year. The train on the left is a new battery train, which we built. In fact, to be honest, we converted it from our original prototype. It's a 3-car total battery train, high specification, fitted with air conditioning and many other features. Now, this train has a range on batteries of 160 kilometers. Now, we operated every day of the conference. So for 2 weeks, we took delegates from all over the world out from Glasgow, out about 25 kilometers and back again. And we did it obviously because we wanted to create a lot of interest, which we've most certainly had. Next, please. You may possibly have heard of the Forth Rail Bridge, which is an iconic bridge in Scotland. It's absolutely huge. And we managed to take our train over it on the Saturday before the conference. And the train went empty 80 kilometers from Glasgow to the bridge and then back again, all on its own batteries. Next. Next, please. There we are. Another view with a bridge in the background and our little train in the foreground. Now, of course, I do realize that India is close to electrifying all of its railway lines, which I think is absolutely excellent. I think it's the right thing to do. But as I said earlier, the UK is never going to get there. And we have an awful lot of lines which are not likely to be electrified for very many years. And I'll talk in the next few pictures about some of the things we're doing about harnessing that opportunity. Next, please. But before I do, I want to just give you a little bit of an idea about some of the costs. People, certainly in the UK and Europe, are keen on advocating hydrogen-powered trains, which are very interesting. With some in Germany, and they certainly work. However, look at the energy cost per train mile, and you see electrification, £1.49. Battery, a bit more expensive because there are some inefficiencies. Hydrogen, however, almost 3 times as much as battery, because the cost of electrolysis of hydrogen from water, that's inefficient, as is the hydrogen fuel cell, which converts the hydrogen back to electricity. Next, please. And again, this diagram shows some of the issues. At the top, we see a hydrogen train. I mentioned the electrolysis is not that efficient, 68%, 52% in the fuel cell. And so overall, from the energy that you put in with electricity on the left, you only get 29% back at the wheel. Whereas if you look at a typical 25 kV EMU at the bottom, you get 83% of the energy that you put in from the electric grid back at the wheel. And battery train, as we just saw, is quite close to the 25 kV train in terms of efficiency. Next, please.
We have a blank slide. I'm just jumping on.
Next, please.
Yeah.
Right. This is the key to using battery trains, because if a battery train is going to replace a diesel one, there's no point in saying, well, every few kilometers has to be stopped and recharged for half an hour. So we've designed and patented an automatic battery charging system. We've started to have many international inquiries about this. The principle is very simple. You see in the track 2 short charging rails. When the train is not there, they are earthed and isolated, i.e. safe. When a battery train comes and parks over them, maybe in a bay platform in a station, the automatic equipment, driver doesn't have to do anything other than stop and take his key out as he normally would. The train talks to the fixed equipment, and providing it proves it's all safe, the train will charge itself from the trackside battery bank. Now we need a battery bank because I mentioned the train earlier on that can go 160 kilometers on charge. If we're going to recharge that in 10 minutes, which we can, we have to put current in, very high current, to transfer the energy very quickly. So we're talking of those charging rails being live at 750 volts and the train taking 1,000 amps from them. Now, it's not sensible to try and get that directly from the local electricity supply. Much more sensible to get it from a large battery, which can then either be trickle charged for 24 hours, or if there's a large solar farm or wind farm in the area, that can be used. Or if electricity is particularly cheap, say in the middle of the night, a larger battery can take advantage of that. Next, please. Will you go very quickly through all these labels, please? Yes, keep going. Next, please. Right. Now, we've extended that concept of the charging system for the train because at many of our stations there are large car parks. And in the UK, there are rapid moves towards electric cars. in place of diesel or electric or petrol ones. However, the provision of charging points is lagging behind that. So we're looking at launching what we call Smart Park, which is a further enlargement of the static battery to also charge cars as well as the train. Next, please. Now, to control all of this, you need to have the right electronics on the train. Previously, we have bought in the traction control unit from a supplier, but because we want to move into a number of different types of application, we decided that we would actually design our own. And this will be the heart of any of our future trains. It's modular, so you would have a small one for, say, a light rail vehicle, right up to a very large one for a heavy freight locomotive. Basically, it's the 4 blocks that you see on the right of the picture are high current solid state switches. The whole is controlled by a microprocessor, which is what the driver interfaces with. The driver will give instructions as what he wants to do, and the software will take signals from all sorts of things, including the speed and many other features. Next, please. Right, one of the projects we have at the moment is looking at converting diesel multiple units. These trains are quite old, but they're in very good condition. The diesel engines are difficult to replace because they're obsolete. Their emissions are quite high. And we believe that we can get a payback, as we said, between 5 and 7 years, mainly brought about by less than half the cost for fuel and less than half the cost for maintenance. There's one project that we're working on. Next, please. The principle is quite simple. Where it says AC motor, that replaces the existing hydrodynamic gearbox driven off a diesel engine. Everything to the left of that is brand new. Bits I've just described. Next, please. We're also looking at converting some DMUs in Germany, because Germany has decided some time ago, in fact, that they want to replace all their diesel trains by either hydrogen or battery trains. So the same principle which we would apply to the UK DMUs would work on some of the European ones, which are incompatible with the UK because of different loading gauge. Track gauge is the same, loading gauge is different, but technology is very similar. Next, please. We've also been asked to look at some locomotives. The one in the top of the picture is a 40-year-old 1,700 horsepower diesel locomotive used typically for short freight trains. And we've been asked to convert some of those to pure battery for use in heavy shunting in intermodal yards, also in quarries. These are in places where there's a lot of local pressure to get rid of diesel engines, particularly diesel locos with very polluting engines, which these have. We would put something like 20 tons of batteries in that locomotive in place of the diesel engine, generator, radiators, etc. We have several customers who are very keen on this as an option. Next, please. Also, all railways, as you know, have plant which goes out to maintain the track. This is one particular type of many in the UK. And of course, these things tend to stop in the middle of the night, and certainly in built-up places like the UK, at the bottom of people's gardens. So it's quite a lot of interest in replacing the diesel engines on them with batteries. Same technology as for the previous ones, great deal of commonality. Next, please. Many lines, as I said, in the UK are electrified. However, many passenger services operate partly electrified and partly not, which means they have to be run by diesel trains, usually DMUs. So this is something that we're doing for one of the train leasing companies, which owns these EMUs, a fleet of them, and they want us to fit batteries to them, shown in green in the picture below, in order to enable them to be able to run about 60 kilometers beyond the 25 kV. We think there's a lot of scope for this, whether in new trains or repurposed older ones like this. Next, please. So here are some of the things we're working on, some of the ones I've talked about. On the left, where it says Greenford branch line, we've just signed a contract with the train operating company, Great Western Railway, and with the government to operate the red line, which is only quite short. It's about 8 kilometers long. It's going to be operated for a year with a pure battery train, which will be the first time a pure 100% battery train has operated a regular service all year. That's just about to start. Next, please.
So this is the last slide.
Good.
Yeah.
Yeah. Okay. So thank you very much.
Yes.
Very happy to take any questions now.
Thank you very much, Adrian. It was, we are also trying battery powered locos and other rolling stock in India, but the range which you are managing to do in the UK is far higher. The way I see the world, whether it's cars, whether it is locomotives, whether it is, I think, any means of transportation, we'll perhaps end with battery powered vehicles only. Mr. Virdi has asked one question. He said, instead of a battery charging point, why don't we try battery swapping points?
Well, because with a battery charging point, we can complete the exercise in 10 minutes or less, whereas a battery swapping point would take a lot longer and would also require plant and equipment and people, whereas the automatic charging point requires no additional people. It's all automatic, providing the driver stops in the right place, which is what I believe we pay drivers to do.
One question that occurred to me was, what type of batteries are you using?
Right. Well, there are many types of batteries. And the first thing we say to customers is that we will future-proof all our products so that as new types of battery come out, we can take advantage of them. In the example I showed you, where we can put 160 kilometers worth of energy back in 10 minutes, those particular batteries are lithium ion. They're a particular type. They're pouch cells. What that means is each cell is hanging in some liquid coolant. Now, the reason for that is that if you're putting a high current into the battery, like anything else, has an internal resistance, and therefore it heats up. So it's absolutely essential to keep the battery temperature well under control. So on that particular type of battery, we have an integral cooling system in the battery module, which is like an aircon system in effect. Now, if we're not charging quite so fast, And for example, two-car train in Scotland I showed at the beginning of the presentation, that would take probably 6 times as long to charge, but wouldn't heat up. And that's still got lithium-ion batteries, but they're just in blocks built solidly together. They don't require a level of cooling.
Thank you, Adrian. Mr. Apur Bahadur is asking, how do you manage this battery in 10 minutes? What's the methodology? Because normally charging the battery would take longer than 10 minutes.
Well, as I said, the key is, first of all, to have a type of battery that's capable of taking a very high capacity charge, very high current. And that's fine, but as I just said, that will heat up quickly. You may remember from school I squared R, which is the heating effect, where I is the current, so it goes up disproportionately, the current goes up. So the key to it is having a type of battery that can be cooled and to cool it and to monitor the temperature. And that's how we do it.
Right now, you're looking at 160 kilometers as the range of the batteries. Any thought of increasing that? And how much do you think you can go up to?
Well, yes. Obviously, we're looking at increasing it. We believe that next year we'll have about 20% more capacity, so you could extend it by that. But then again, the 160 depends on the configuration of the train. Depends on the weight of the train, how many batteries you put on it. We could put more batteries on that train. It also depends on how fast you want to go, on the gradients, and all kinds of things. So one of the things that we've got quite expert at doing is doing simulations of the actual current consumption on various different routes. And customers come and say, how much electricity will they use? So we have to ask them all those questions. How many station stops they want to have, what are the gradients, etc., etc. And they can all be calculated. But in general terms, we certainly should be over 200 in some cases. Of course, in many cases, not actually required, because there are quite a lot of short lines where train terminals can be recharged anyway.
See, one of the ideas being put forward in favor of electrification and for using batteries is that at the point of consumption, there is no pollution. Of course, there will be pollution at the generation point, but that is normally away from populated areas, so that where the vehicle is being used, the pollution is virtually zero.
That's right, yes.
Now, if you have, whether you have a battery or a, say, direct electrification, in both cases, you have to have electrical generation at some point.
Yes, true.
From what I could make out, the losses in converting the electricity first to a battery and then to transportation, the losses are higher from the point of generation to the point of usage. So wouldn't the pollution be higher in the case of batteries when compared to direct electrification?
Well, okay. Two answers to that. Depends on how the electricity is generated. Now in the UK, we've made very rapid progress towards pollution-free generation. In fact, on average, more than 50% of our electricity in the UK is now generated either by wind or, believe it or not, by solar. Now, in a country that rains all the time, solar seems a bit improbable, but it does contribute. Obviously, in India, it could be a lot higher. Now, much of the rest is made up of nuclear, with very little coal power generation in the UK. It's only about 5%, and some days it's zero. The rest being oil or gas, rather. So that clearly needs further attention. Our government is very keen on doing it, obviously outside the scope of this talk. But as I showed in one of the earlier slides, yes, a battery train is somewhat less efficient from power station to wheel than a straight electric train. And I've always believed that proper electrification is the right thing to do where it possibly can be done. And I know in India you're doing it everywhere. In the UK, that is never going to happen. And only about a third of our network is currently electrified. So for many, many, many years, there will be much of it, admittedly quite lightly trafficked, but much of it which will not be electrified.
Mr. Apurva Bahadur has another question. He asks, how do supercapacitors compare to lithium batteries?
Well, supercapacitors, we don't use them, but I know some other manufacturers do. And they can store a lot of energy, as you know, but dissipate it fairly quickly. We're not generally in a position where we want to have a big kick. We just want to have a continuous supply. So we don't use them, but I'm aware some others do.
One last question. Perhaps the vehicle that has been using batteries since it started was the submarine.
Yes.
It ran on batteries. But submarine battery, are you the same type of batteries or different batteries?
Well, the company that at the moment supplies our batteries has had many years supplying batteries for submarines. So whilst the technology is not identical, it's certainly drawn on experience from submarines, where the idea, I gather, is that when you come up to the surface to recharge your batteries, you want to do it quite quickly before your enemy spots you. So that technology is an example of technology transfer from one industry to another.
Okay. So, Apurva Bahadur has another question. Are all your motors
my question was about the all motors AC. I mean, your technology in the heart depends on traction converters and three-phase squirrel cage.
Yes, all armed traction motors are AC. That is correct, yes.
Thank you, sir.
Since we have no more questions coming in, we can end here, Adrian. Thank you very, very much for a talk that has been very enlightening for us in India, because we've also been thinking of battery-powered locomotives and battery-powered vehicles for a long time. We are just the beginning of converting locomotives, existing locomotives, to battery-powered, and also for the manufacture of new battery-powered vehicles. So I'm sure we can pick a lot from your ideas. Thank you very much for an enlightening talk.
Well, I very much enjoyed, and I look forward to seeing you in a few days.
Yes,
Thank you once again.
Yeah.
Thank you.
Back to you, Manoj.